Hello students, today we will see the important concept of the probability, that is the Bayes theorem. Now in the Bayes theorem, the first thing we want to know that the partition of a sample space. Now what is the partition of the sample space? A set of events E1, E2 and En is said to represent a partition of the sample space if first EI intersection EJ is equals to phi, where I is not equals to j and I and j is equals to 1, 2, 3 up to n. B, E1 union E2 union En is gives us a sample space S. And third, all the probability is greater than 0, that means positive. Okay, so these three things we have. When we say that the set is a E1, E2, En are the partition of the sample set. Partition means we have to divide in the disjoint things. Okay, no things are connected to each other. No events are connected with each other. That is the thing, the partition of the sample space. Now let us see this concept with an example. So what is a partition? So here I have taken one event S. S is a throwing a dice once. Now when we throw a dice once, we have a 6 events in that getting 1, getting 2, 3, 4, 5, 6. So these are the events of this S. Okay, here we can consider, let me take in E1. E1 is equals to 1, 2 and 3, getting 1, 2 and 3 on the dice. Okay, E2 I can take 4, 5 and 6. Okay, so E2 event is 4, 5 and 6. Now here obviously E1 is equals to 1, 2, 3. E2 is equals to 4, 5, 6. So E1 intersection E2 is 5 and E1 union E2 is equals to S. Now probability of E1 is equal 3 by 6, 1 by 2, that is greater than 0. Probability of E2, that is 3 by 6 is equals to 1 by 2, is also greater than 0, and therefore E1 and E2 are said to be a partition of the sample space. Okay, what we require to form a partition of the sample space, that these two events must be disjoint, that means intersection must be empty, union is equals to S, and probability is positive. Okay, and thus again I am saying the third property will be solved always, but first and second we have to show that E1 intersection E2 is phi and E1 union E2 is equals to S. Same sample space, we have taken another example. So here the second example we have. Let E1 is equal singleton 1, E2 2, E3 3, E4 4, E5 5 and E6 6. So these 6 event, now obviously these 6 are disjoint because they don't having any common element. E1 and E2 5, E2 and E3 5. Okay, no common element. E1 and E3 5, E1 and E5 5. So here I have written that E1 intersection E2 5, E1 intersection E3 5, E2 intersection E3 is 5 and so on. So therefore EI intersection EJ is equals to phi for all I and j is equals to 1, 2, 3 up to 6. Okay, where I and j are different. And E1 union E2 union E3 union E4 union E5 union E6 is equals to S. So therefore E1, E2, E3, E4, E5 and E6 are said to be a partition of the sample space, and no need to check the probability because obviously probability of E1, so 1 by 6 positive, E2 one element only, 1 by 6 positive. Similarly you can solve for the another one. Okay, so this is the first concept of the Bayes theorem, that is the partition of the sample space. Okay, now the second thing, again the important one, is the theorem of total probability. Okay, so now let me see what is the theorem of the total probability. Let E1, E2, E3 and En be a partition of the sample space S, and suppose that each of the event E1, E2, En has non-zero probability of occurrence. Let A be any event associated with them, then probability of A is equals to probability of E1 into A by E1 plus probability of E2 into probability of A by E2 plus so on up to probability of En into probability of A over En. Now this is the one of the things we can say important things to be understood. So what is the total probability? टोटल प्रोबेबिलिटी में क्या है कि आपके पास E1 E2 En ये तो डिसजॉइंट इवेंट है ही, बट वी कैन कंसिडर एनी अदर इवेंट A which is associated with the S. Okay, so therefore we can find out this probability of A by this formula: probability of E1 into A over E1 plus probability of E2 into probability of A over E2 plus so on this. So this is known as a theorem of total probability. Now let me explain this with an example. So here I have taken S, throwing a dice once. Again easy example so you can understood better. So 1 2 3 4 5 and 6. Okay, this is the sample space. Now E1 and E2, E1 1 2 3, E2 4 5 6, two disjoint events. Now let A getting a number multiple of 2, that is any other event A which is related to S. Okay, which is related to S, the getting a number the multiple of 2. Now if we take multiple of 2, then it is A is equals to 2 4 and 6. So we can directly find out probability of A will be 3 by 6 1 by 2. Now let me see by the total probability theorem. Okay, by total probability theorem. Now how we can do this? So here E1 1 2 and 3, so probability of E1 will be 3 by 6, that is 1 by 2. Okay, now E2 4 5 and 6, so probability of E2 3 by 6, that is 1 by 2. Now for the total probability theorem we require A by E1 and A by E2. So A by E1 we require probability of A intersection E1. So let me write down A intersection E1. What can be A intersection E1? So A intersection E1 is 2. You can observe here A is equal to 2 4 6, E1 is equals to 1 2 and 3. So here A intersection E1 is 2. Now probability of A intersection E1, that is 1 upon 6. Similarly A intersection E2, you can observe here 2 4 6, 2 4 6 and 4 5 6. So here the common element are 4 and 6. So probability of A intersection E2 is 2 over 6, so 2 by 6. Now let me find out probability of A over E1. So it is probability of A intersection E1 upon probability of E1 by the formula of conditional probability. 1 by 6 upon 1 by 2, that is equals to 1 by 3. Probability of A over E2, probability of A intersection E2 upon probability of E2, that is 2 by 6 into upon 1 by 2, that is 2 by 3. Now let we use the theorem of the probability. Now what is the theorem of the probability? That is probability of E1 into probability of A over E1 plus probability of E2 into probability of E over E2. All things we have found. Probability of E1 is 1 by 2, A by E1 1 by 3, probability of E2 1 by 2, A by E2 2 by 3, 1 by 6 and 2 by 6, that is 3 by 6 is equals to 1 by 2. Okay, now let me see what is the probability of A we have found, 1 by 2. So here we have, so probability of A is same as probability of E1 into probability of A over E1 plus probability of E2 into probability of A over E2. So this is known as the theorem of total probability. Okay, here again I am saying that in the theorem of total probability, what we required, E1, E2 and En, E1, E2 up to En are disjoint events. Okay, or not connected event, independent event of the sample space, and A is any other event which is associated with the sample space S, that sample space only, and then we can find out the probability of A is known as a probability of E1 into probability, this is known as a total theorem. Probability of A, that is equals to probability of E1 into probability of A over E1 plus probability of E2 into probability of A over E2, so on up to probability of En into probability of A over even. I hope so that you should understood these two topics of the Bayes theorem. Now third thing in this, which is a Bayes theorem, this will be shown in the next video. Till that, if you have a doubt in anything, you can give me a comment. Okay, so again, have a nice day. Let me see in the next question.